We present DreamBooth3D for subject-driven, text-to-3D generation. Given a set of 3 to 6 casual captures of a subject, DreamBooth3D learns to optimize a NeRF volume of that subject given a text prompt. Our approach is based on 2 recent lines of works that leverage text-to-image diffusion models. First one is the personalization of diffusion models such as DreamBooth and textual inversion, which proposes subject-driven generation via prompt or model fine-tuning. However, the generated images lack any 3D control. Another set of recent works enable text-to-3D generation using diffusion models. DreamFusion, for instance, proposed a novel SDS loss to optimize NeRF volume for a given text prompt. However, the generated assets cannot be grounded to a particular subject. A naive combination of DreamBooth and DreamFusion does not produce meaningful 3D assets as shown here. A key issue we find is that DreamBooth usually overfits to the subject viewpoints in the input images. We present our approach next. We propose a novel and effective 3-stage optimization scheme for subject-driven text-to-3D generation. Given a set of subject images, we first construct a partial DreamBooth using these input images. We then use the partially trained DreamBooth to optimize an initial NeRF volume using the SDS loss. The partial DreamBooth tends to overfit less to the given subject views, and thus stage 1 produces a 3D consistent NeRF model that has partial likeness to the given subject. We then render the NeRF volume from a set of predefined views and use a fully trained DreamBooth model to generate multi-view subject images using image-to-image translation. We use the generated multi-view images along with the input images to further fine-tune the partial DreamBooth, which we refer to as multi-view DreamBooth. We then use this multi-view DreamBooth to learn a final NeRF volume using the SDS loss. In addition, we also use a weak reconstruction loss to improve subject fidelity. Next, we show some results. Here are some sample DreamBooth3D results. Our model can generate 3D consistent NeRF volumes with high subject fidelity from as few as 3 to 6 casual captures. Here, we compare our results with the baseline DreamBooth plus DreamFusion and latent NeRF, another recently proposed text-to-3D approach. Our framework produces sharper and more consistent geometry compared to the baselines. We also conduct a user study to demonstrate 3D consistency and subject fidelity and prompt fidelity of our approach. Our method outperforms both DreamBooth plus DreamFusion and latent NeRF. Our framework allows versatile 3D generation with simple modifications in the text prompts. Next, we show some sample applications. Here, we show some material editing results. Notice that the glass sculpture and the statue of the dog correspond to the given subject. Our model can add accessories directly onto the 3D subject, as in the tie and suit on the cat, or into the scene, as in the rainbow carpet and green umbrella. Here are some color change results. DreamBooth3D can introduce color changes in a consistent manner. We can even perform non-rigid deformations such as pose changes relatively easily with simple modifications of text prompts. Here we show different dog subject results in various poses. Note that none of the exemplar images contain an image of a jumping or sleeping dog. To summarize, we present DreamBooth3D, a novel and effective optimization framework for subject-driven text-to-3D generation from a few subject images. DreamBooth3D can generate 3D assets with high subject fidelity in terms of both geometry and appearance. DreamBooth3D also enables several 3D editing applications with simple changes in the text prompt. Thank you. Please see the paper for more details.